Now this also forms oxides. It does not form the pure metal. Then why do we employ this technique? The reason is that oxides are, the element is easier to extract from the oxide rather than the sulfide or carbonate. This is very important because very frequently they ask this question, that why is zinc sulfide and zinc carbonate are converted to oxides before they are and not directly reduced to the pure metal. So the thing is that, they are difficult to reduce to the pure metal, but it is when they are converted to oxide, the oxide is easy to, the metal is easy to get extracted from the oxide rather than the sulfide or the carbonate. So very frequently asked question. This is the reason. Okay, so now you have got the oxide. Now what to do? As we have already seen that metals of medium reactivity, I have said that they'll not just get converted to the metal by heating the oxide. So what to do with the oxide? How to get the metal? The thing we use is carbon. We use it in the form of coke. Now this carbon acts as a reducing agent. Now, what is a reducing agent? Which either removes hydrogen, removes oxygen, adds hydrogen, or removes an electronegative element and all these, adds electrons and stuff. So in this reaction we are mainly concerned about removal of oxygen. So what carbon does is that it just gives Zn and it forms CO. What is CO? Carbon monoxide. So simple reaction, just ZnO plus C will give Zn plus CO, and carbon is used as a reducing agent because carbon takes away this oxygen from zinc, and since it snatches away this oxygen, zinc is deprived of oxygen, so it gets reduced. And who is doing this? Carbon, because it is taking away the oxygen and forming carbon monoxide. You should know that a reducing agent always gets oxidized in the reaction, and an oxidizing agent always gets reduced. See, carbon reducing agent, but it gets oxidized to carbon monoxide. ZnO here is the oxidizing agent because it gets reduced to zinc. It donates its oxygen to carbon, and carbon takes away this oxygen. So this technique is used. Now, we were talking only about Zn, but there is another method in which we can incorporate manganese and iron as well. Here C. Instead of using carbon as the reducing agent, we can use another element as a reducing agent. And this is what happens in case of the oxides of manganese and iron. In manganese dioxide, MnO2, you use aluminium as reducing agent. So what it does is that it forms aluminium oxide and it gives you manganese. And the balancing is this. And this reaction, see, aluminium snatching away oxygen from manganese and becoming aluminium oxide, and manganese giving away oxygen to aluminium becoming manganese. So what is the oxidizing agent over here, which itself gets reduced? So manganese dioxide gets reduced to manganese because it gets deprived of oxygen. So this is the oxidizing agent. And aluminium, which gets oxidized to aluminium oxide, is our reducing agent. And in this reaction, the reaction is so exothermic as it forms a very large amount of heat. It forms such a large amount of heat that this metal manganese actually is formed in liquid form. It melts due to the heat. And a similar reaction with Fe2O3 This reaction also is very exothermic, and iron is formed in liquid form. And this reaction is used for welding railway tracks. You know, there are cracks, sometimes there are cracks in railway tracks. So what they do is that they take Fe2O3, they put Al in it, and they get Fe in liquid form, and this liquid Fe they fill in the crack, and then it then solidifies, and so the crack between the two is filled with iron, and so the track is welded. And this reaction of Fe2O3 and Al has a special name. It is called the Thermit reaction. So from here they can ask you questions like, why is iron formed as liquid in Thermit reaction? So the answer is that the reaction is very exothermic, and the heat evolved actually melts iron. So iron is formed in liquid form. Or they might ask you questions like, which is the oxidizing agent, which is the reducing agent in this reaction, or what gets oxidized and what gets reduced. So in here you always have to remember that oxidizing agent gets reduced and reducing agent gets oxidized. And obviously the one losing oxygen is getting reduced, the one gaining oxygen is getting oxidized. and of course you have to write the reaction.